Lately, I've been getting into microcontrollers, and while browsing the internet, I came across this little thing, the ESP32C3, and honestly, this board is mad. It's tiny, about the size of a coin, barely uses any power, and it's absolutely packed with features like Bluetooth and Wi-Fi, which makes it perfect for smart home automation. What's the best part? It's cheap. Some of these boards cost as little as $1. So for my first microcontroller project, I wanted to build something simple, affordable, and something I can actually use. That's why in this video we're going to be building a smart home temperature and humidity sensor that works with Home Assistant. Home Assistant is a free and open source home automation platform that gives you full control over your smart home devices in one place. Instead of using lots of different apps, Home Assistant lets you manage everything together and build powerful automations really easily. It's most commonly ran on a Raspberry Pi or mini PC, but for this video I'll be using a mini PC. To connect our microcontrollers to Home Assistant, we'll be using ESPHome, which makes adding ESP32 devices to Home Assistant super simple. So let's talk about the main part of the project, the microcontroller. For this build, I'm using the ESP32C3. These boards are small, cheap, and extremely capable. You can find them on AliExpress or most electronic websites. An important thing to keep in mind when using these boards is that they run on 3.3 volts and also 5 volts. So it's important not to mix them up, because using the wrong voltage could damage the board. They are so affordable, so I'd recommend picking up a couple extra, and they're great for other projects as well. Next, we need a sensor that can measure both temperature and humidity. To make sure everything works smoothly with ESPHome, it's great to start with the ESPHome components page. You can find the link below. It lists sensors that are already supported and shows exactly how to set them up, which is super handy. After looking through the options, I chose the SHT31D sensor. It's accurate, reliable, and communicates using the I2C protocol. Once I knew it was compatible, I went back on AliExpress and ordered the same sensor for just a few euro. So now that we have the ESP32 and the sensor ready, let's get everything together and start building the project. This is everything you'll need to build the project. Firstly, you'll need a breadboard, the ESP32C3, the SHT31D sensor, jumper cables, a USB-C cable, and then a power source. The wiring for this project is fairly simple. First, we're going to add the ESP32 onto the breadboard. Next, we're going to add the SHT31D sensor onto the breadboard. Then we're going to grab a jumper cable and connect it to 3.3 volts on the ESP32. Then we're just going to connect that to VIN or power on the sensor. Next, we're just going to connect ground on the ESP32 to ground on the sensor. Next, we're going to connect GPIO 5 on the ESP32 to SCL on the sensor. Next, we're going to connect GPIO 4 to SAA or relative humidity. So this is just our data cable. And that's the wiring done, only 4 cables, super simple. To program our setup, you could use something like Arduino IDE or even Python, but for this project I'm going to be using ESPHome because it makes connecting microcontrollers to Home Assistant much faster and easier with very little code. To install ESPHome on Home Assistant, you just want to go to Settings, and then you want to click on Add-ons. There you want to click on Add-on Store and you'll see ESPHome. You just want to click Install, give it a few seconds, it should install. Then you want to add to sidebar. This just puts Home Assistant on the left hand sidebar, makes it much easier. Then you can click Start and boot up your ESPHome builder. Then you can navigate to the sidebar and click Add Device. You can just click Continue, this is just telling you to plug in your device. Then you can just click New Setup. Then you want to name your device, so I'm just going to name it Sensor. Now this is important, you want to put in your network information, your network name and network password. This just automatically means that ESPHome knows your network and password, so you don't have to fill it in every time you want to build a new device. Then we want to click the ESP32C3 and we can just skip the encryption phase for now. Then you want to click Edit. We're just going to start to edit the YAML. So you want to just press Enter down from the captive portal. It'll automatically generate the first few lines of code, but this is where we're going to add the sensor information. So first we set up the I2C communication. This tells ESP32 which pins to use to talk to the sensor. SDA is connected to GPIO 4 and SDL is connected to GPIO 5. And then with the scan set to true, ESPHome will automatically detect I2C devices connected to the board. Next we add the sensor itself. The platform we're using is the SHT3XD, which is the driver for the SHT31 temperature and humidity sensor. We create two readings, one for temperature and one for humidity, and we give them names so they show up clearly inside our Home Assistant. The sensor address is set to 0x44, which is the default I2C address for this module. Finally, the update interval is set to 10 seconds, so it'll send readings every 10 seconds. So now that the code is finished, we can click Save and plug the ESP32 into the device which is running our Home Assistant. Then you want to click Install and then select Plug into the computer running ESPHome Builder. Then select your device. The firmware will now compile and upload to the board. This could take a few minutes. Once it's finished, you should see now that the device is online. You can view the logs in a few different ways, either wirelessly over Wi-Fi from the PC you're using or directly using the Home Assistant PC. Once in the logs, we can see that everything is working perfectly. If you're having any issues, it's great to use the logs to help troubleshoot. The next step is adding the device to Home Assistant. If we go to Settings and then Devices and Services, if everything is working properly, you should see the sensor appear in Discovered section at the top. If it appears there, just simply click Add. If you don't see it automatically, you can manually add it by selecting ESPHome from the integrations list, then enter the name of your device followed by .local. The default port for ESPHome is 6053. Once connected, the device will appear in your Home Assistant dashboard. You can now see both temperature and humidity sensors available. From here, you can create powerful automations like controlling heat in specific rooms or automatically switching on dehumidifier when the humidity gets too high. The sensor works perfectly fine on the breadboard, but I wanted to make it look a bit cleaner and give it some proper protection. So I designed a custom enclosure using Fusion 360 and sent it over to my Bamboo A1 3D printer. The print took about an hour and came out really well. The design uses M3 brass heat inserts, which work great with 3D prints because they allow you to securely fasten screws without damaging the plastic. Both the ESP32C3 and the SHT31D are mounted using M3 screws, and the lid is also secured using an M3 screw. The case includes openings for ventilation, so air can still flow to the sensor and still take accurate readings. If you're interested in the case, you'll find it in the link below where you can purchase the files from Etsy. If you don't have a 3D printer, you can also purchase the finished case with everything included for just a few quid. And that is it, a simple, affordable, smart home temperature and humidity sensor built using an ESP32 and Home Assistant. If you enjoyed the video, make sure to subscribe. Drop a comment below if you liked the video, and if you have any other questions, just let me know. I'd also like to hear any projects you'd like to see me do next.